will join. So, at the outset, I welcome all the colleagues from our institute as well as larger maize family, our ICAR colleagues. This topic is very close to, I think, heart of all the readers. So that's why I specifically asked that from AICRP all the readers to join. But it is not that others are not welcome. But you know that unfortunately, though our program is one of the oldest program, but in between our emphasis got shifted that you sell best single cross hybrids and derived lines, and accordingly then again put them in combination. So in the process, I always say that we may get some good hybrids, and we did get good hybrids, but this is not very a systematic process. So heterotic grouping is that where we know the heterotic behavior. If a line is derived from one group and it is crossed to another line from other group, that is likely to give heterosis. Certainly in maize, if we cross two inbreds, we are certainly going to get heterosis. But how? At what level? So initially, theoretically, it looks to be very easy to do, but when we started practicing, we encountered certain problems. And I think Dr. Pardeep and our other scientists have gained good experience. So that's how I requested Dr. Pardeep to deliver this particular talk on heterotic grouping principles and practices. So now, Dr. Pardeep, over to you, please.
Thank you, sir, for giving an overview regarding heterotic grouping. Good afternoon to all respected director and dear colleagues from IAMR and Active Center. And today I'm going to present a seminar on heterotic grouping principles and practices. Actually, we planned this seminar for a heterotic grouping because earlier we followed the only one approach based on the SCA method only. Then recently we studied the different method on heterotic grouping, and accordingly I prepared this seminar. As we know that narrow genetic base is one of the most important limiting factor, not only for maize, it is for all the crops in case of yield improvement, and also a bottleneck in maize breeding program also. Further, if we formed a new heterotic group based on the different tester or different heterotic group based tester, then we can clearly classify our inbred line into two heterotic groups. And if we make the crosses between two heterotic groups, then our yield or the yield of that hybrid will be higher compared to the same heterotic group. This is the outline of my seminar, the concept of heterotic group and pattern maize heterotic groups in the world, how they are making the heterotic group in different countries, and the different strategies they are following for making the heterotic group. As we know, the heterosis concept given by Searle in 1914 in maize, and explain that heterosis is the superiority of the F1 over both the parents in terms of yield or other economic traits. And the heterosis is due to the high degree of heterozygosity in the genome, that is the presence of different allele at many loci in the homozygous chromosome. And the heterozygosity of the parents or inbreds may be increased by crossing genetically distinct parental material or material belonging to distinct heterotic groups. So heterotic grouping means identify germ plants groups that are genetically distinct from each other and that produce superior hybrids when it crossed. And as we can define the heterotic group or a heterotic pattern, the heterotic group is related or unrelated genotypes from the same or different population, which display similar combining ability and heterotic response when crossed with the genotype from other genetically distinct germplasm groups. Similarly, like a heterotic pattern, a specific pair of two heterotic groups, which may be population or line that express in their cross high heterosis and consequently high hybrid performance. The concept of heterotic pattern include that a subdivision of the germplasm available in hybrid program in at least two divergent populations. And these two population heterotic pattern are typically improved as follow. That the progenies are generated within the same heterotic pool. The progeny are then evaluated for yield, performance, and test cross with tester from opposite heterotic pool, and line those showing superior test cross performance are intermated to form the next cycle of selection or maybe as a hybrid. Then what is the importance of that or any heterotic pool? That line developed out of one population is genetically related. So if we made a hybrid from a genetically related lines, it saw the low degree of heterozygosity and it ultimately lead to lower hybrid vigor or low yield. Then maintaining the genetically distinct heterotic pools lead to increase the allele diversity among heterotic pool or increase the degree of heterozygosity and ultimately increase the heterosis or hybrid vigor. If we talk about the heterotic pattern in US germplasm, initially they formed the two heterotic group based on the seed type, means den type and flint type. So basically they formed two heterotic group around in 1920, den type and flint type. In later on in 1950, they when they transitioned the maize program into the single cross hybrid, they made two clear-cut heterotic group, that Iowa steep stalk synthetics and non-steep stalk. And that heterotic group is still continuing. That if we see the two heterotic group, clearly they have formed that one group they are used only for development of the seed parental line and other mainly used for pollen parental line, and make the hybrid between these two heterotic group for higher yield. Similarly, in the Central and Western Europe, they are also following US dent line and European flint type. In case of China, basically they are classify the heterotic group based on their own germplasm, those which they are derived from the local OPV or land races, and other groups they are found from the whatever germplasm they are imported from the other countries. And in case of tropical germplasm, basically there are several group formed like Texpino, Kitale, Pool 9A, Swan, and Flint Den type also. Now what are the strategies the researchers are following for heterotic groups? Basically, the Wassel given the concept of classifying the lines into heterotic group based on the specific combining ability. Later on, the person modified and considered the mean also. Then they are classified based on the specific combining ability and those lines which are having the higher mean yield. Later on, the person are considering for GCA also, those lines which are having higher GCA, and the line included in those crosses having higher mean yield and SCA. These three also consider. And later on in 2008, Fan et al. Giving the concept of HSGCA, heterotic groups, specific and general combining ability. He explained that for classifying the line into different heterotic group, the role of the GCA is also a very important. So GCA and SCA both should be considered for classifying the inbreed lines or lines in germplasm into two heterotic groups. Later on, the concept of HSGCA-MT, heterotic grouping based on the general combining ability of multiple traits given by Badru Apraku in 2013. And he explained that whatever heterotic grouping method, GCA or SCA, these are based only on single trait, only on yield. And if we talk about the grain yield, is a complex trait and controlled by polygene and has low heritability, especially under a stress environment. So yield is difficult through direct selection under a stress environment, and it is more effective in a selection to use component traits that are directly correlated with the yield. And he explained that GCA of multiple trait should be used for heterotic grouping. And the recent concept that most of that clear-cut heterotic grouping used by molecular marker or SNP based data. That this is the older concept given by the Melchinger and Gumbar, that the whatever germplasm you are having to just test cross with the two tester and identify the two heterotic group based on the higher yield and lower yield. And in the strategic race 1967, given that combine the germplasm in one synthetic random matting, and random matting create the two population. The SCA based grouping as per Vassal 1992, positive SCA effect indicate that line are in opposite heterotic group, where negative SCA effect indicate the line are in the same group. He given the concept that, and when the lines showing the negative value with both the tester, it will be rejected, means it is not belonging to these two tester heterotic group. And if a line showing the positive value, positive SCA value with both the tester, it means the line belongs to both the tester or both heterotic group. Later on, they consider that SCA and mean based means the lines with any tester showing the higher yield, that line only can be classified into different heterotic group. If we can see in the first line and two line, they are showing the higher yield for one tester or two tester, then accordingly they can classify, and those lines which are having low yield, they cannot classify into any heterotic group. Later on, the GCA, SCA and mean based, the higher yield with SCA effect also considered to classify the inbred line into different heterotic group. Simultaneously could classify only those lines which are having positive GCA effect only. In this case, we will consider SCA also and higher yield, and the lines which are having positive GCA effect. Then what is the role of GCA and SCA for a heterotic grouping? As per Griffin 1956 model, the mean yield or mean grain yield consisted of both GCA and SCA effect. Hence, GCA effect can also be used in classifying maize heterotic group. Then Fan et al. In 2008 conducted an experiment to classify the Chinese temperate line of non-heterotic group using the tropical tester YML146 and YML149. These belong to Swan 1 and Textrino respectively. Then Fan et al. Concluded in their finding that when a line was crossed with different sets of maize germplasm grouped by the four heterotic group, not only the SCA effect of its crosses but also its GCA effect varied. Then he suggested that not only to consider SCA effect to classify in the different heterotic group, GCA effect should also be considered. Then accordingly, the Fan et al. Given in 2009 given the model to calculate the HSGCA, and this is the model. Cross mean is the mean yield of the cross ith and jth tester, and Xj is the mean yield of ith tester and Xj is the mean yield of jth line. Or simply we can sum the GCA plus SCA. Here I explained the how to calculate HSGCA. This is the GCA of line 1 and this is the SCA of line 1 and T1 0.34. So we can sum the L1 GCA plus T1 and L1 SCA. Similarly for T2, then we have to calculate the HSGCA, and based on this, in the next slide, I will explain that how we can identify it. And they have explained the three procedure, how to place the line into different heterotic group. First one, the place all inbred lines with the negative HSGCA effect into the same heterotic group as their tester. And second one, if an inbred line was assigned to more than one heterotic group in step 1, we kept the line in heterotic group if its HSGCA had the smallest negative value. Means if we, in the first step, just they explained whatever lines showing negative effect with the tester, then it can be classified in A group. And secondly, it may be happen it may show the negative value with both the tester. Then we have to consider the smallest negative value and accordingly to assign into the heterotic group. Like we can see here in line number 3, the both the line showing HSGCA effect with both the tester negative. Then here we have to consider highest negative value. So accordingly, it is classified into B group. And if a line had positive HSGCA effect with all the representative tester, we are cautious to assign that line into any heterotic group. Means that line is undefined or not belong to these two testers which are taking into study. And as I explained,
Dr. Pradeep, can you go back to the previous slide?
yes, sir.
Third line you are putting in B group, and second also you're putting in B group. Can you explain it once more? That
Yes,
that means we need to have a negative value, then only we'll be able to put them in
similar group. Similar group. Suppose that, sir, in T1 I given the A group, and T2 I have given the B group.
Digvijay Swine, please.
Here, sir, if we see the line 1 showing the negative SCA effect with tester 1, it means it will go into A group. Similarly, if line 2 giving the negative value with the B group or tester 2, it will go in the B group.
So, and so here the HSGCA should be negative. First, that is the first criteria.
Yes, sir.
Why we are taking as a negative as the criteria?
Sir, it actually, if we consider to classify into two heterotic group, they consider negative, but as per my knowledge, whether they can consider as positive or negative, that also can be found. But they explained only negative.
Can you go to the previous slides? Yeah, it is L1 GCA plus T1 SCA.
L1 T1 SCA.
L1 T1 SCA.
Yes.
So this negative, why it? Because if GCA is negative, is it a very desirable trait?
Sir, even that in Vassal paper also, for based on the SCA effect, he also explained the whatever lines showing the negative SCA value with the respective tester, it will go in the same tester group.
That is fine. That is fine. Yes. But now suppose if a line is having high GCA.
Yes, sir.
But then it will not give a negative value, no?
No, sir.
Now, in your next slide, what you are showing, like suppose fourth case.
Yes, sir.
Fourth case, it is giving positive GCA,
Yes.
HSGCA.
Yes, sir.
So you are not grouping them. But my
Yes, sir.
question is that if the particular genotype is having very high GCA,
Yes,
which
sir.
is always desirable,
Yes, sir.
so in that case, it will give you positive HSGCA only, na? But in that case, you will not be able to group them.
Yes, sir.
So that is my question, that why it is so. What is the logic they are using? Can anyone throw any light? Dr. Shahi? Or anybody else? Sudha?
Dr. Pradeep, I think the significance level should also be there here. No? If you have a positive and significant, then it will go to the opposite heterotic group.
In case of HSGCA.
SCA. Here you are
SCA.
describing SCA.
Okay. Sir, actually there are different papers now. Someone have considered significant, also someone have not considered.
In in that case, if we have a non-significant value, then we put it in the unidentified group. If we have significant level in with one tester, then it will go to the opposite tester in the group of opposite tester.
That is fine, but here he's taking into consideration the GCA also.
Yeah, here he has not taken the significance level. Here only the GC and SC.
My question is, Pradeep, that if the GCA is very high.
Yes, sir. Yes, sir. I understood your question. It will not be classified because even if GCA is high and if one another tester it is negative, then it will become also positive.
Yeah. So anybody else?
No, I think.
Dr. Shai?
Yes, I don't know, sir. Yeah, this is 1.89 and 3.89. I think why it is undefined. Only on the basis of SCA effect.
No. It is HSGCA. HSGCA is GCA plus SCA of that particular line with that particular tester.
GCA effect of the lines. High HS GCA. This is HS GCA by Luch. 1.89 and 3.89. I think.
Sir, that is not a GCA. It is GCA plus SCA. GCA of the line will be per se again. High GCA, high mean, and values you have to look, sir.
Is there any relationship between, I think, can we consider some heterosis percent and as well as SCA effect relationship here?
No, sir. No, sir. High GCA, high line performance, and this grouping. You have to consider all three, sir.
No, that is another way, but I am talking about HSGCA, that here if a line is having very high GCA, positive GCA, okay, so in that case it will have a positive.
Sir, definitely, sir. This is a half information, sir. That Fan et al. Paper, the data can be shown from his table, sir. Then we can understand, sir. Basically, Dr. Pradeep has taken an example. The whole classification that has been discussed in Fan paper, if that clipping or that table can be taken, it is very clear there, sir.
Pradeep, do you have that particular table?
Yes, sir. Okay. He explained 3 steps. I will share that paper also. Shall I?
Yeah, please proceed. Please proceed. Pradeep, are you going to share that paper or?
Yes, sir. Yes. Sir, is it visible?
Yeah.
If we can see here, the first step is the placed all inbred line with negative HSGC effect into the same heterotic group as their tester. All 23 inbred line except CML 166 were classified into 4 non-heterotic group. At this step, a line might be assigned to more than one heterotic group. Second step is if an inbred line was assigned to more than one heterotic group, in step first we kept the line in the heterotic group of its HSGCA had the smallest value or largest negative value and removed it from other heterotic group. And third one is the if a line had a positive HSGCA effect with all the representative tester, we may cautious to assign that line into any heterotic group because the line might belong to a heterotic group different from the 4 tester.
Okay. Okay. You carry on. You carry on your presentation.
Then later on, the Badu Prakku et al. 2013 given the concept that general combining ability of multiple traits that not only consider the SCA effect, and this is specifically followed in the different test environment or a stress condition where we can't directly select the yield trait. Then we have to consider the contributing traits. In this method, the heterotic grouping by this was achieved by standardization the GCA effect mean of 0 and a standard deviation of 1 of all traits that had significant mean square test across the environment to minimize the effect of different scale of the traits. And the standardization of the GCA effect may be done by giving the formula or by scaling in the R software. Then accordingly, the different method by heterotic grouping by different method SCA, HSGCA or HSGCA MT. Accordingly, we will estimate the breeding efficiency, and based on that, we can identify that which one the breeding method is more efficient. And according to Fan et al., an efficient grouping method is one that permits isolation of more high-yielding hybrid among the intergroup crosses than among intra-group crosses. And the breeding efficiency can be defined as percentage of superior high-yielding hybrid obtained across the total number of intercrosses. In this case, the total number of hybrids or crosses we can divide it into 3 groups: higher yielder, medium yielder, and lower yielder. And accordingly, we can classify that each group. In first group, how many intergroup hybrids, high yielder, or within group how many, and in the medium group also intergroup and within group, and accordingly by this formula we can calculate the breeding efficiency. And based on that, we can find that which method is more efficient to classify the lines into different heterotic groups. That in Fan et al. In 2019 found that HSDC method increased the maize breeding efficiency 16% over the SSR method and 23% over the SCA method. And he explained that HSDCA method is more efficient even compared to SCA and SSR method. Similarly, Badu Apraku et al. In 2015 found that SCA and HSGCA method are similar in based on the efficiency. And compared to HSGC MT and SNP based method is more prominent compared to all the methods. And similarly in OA Tunde 2020 found that HSGCA and HSGCA method is more efficient compared to HSGCA MT, SCA and SNP based on the different environment. And this is the Olai 2021 published one paper in Heterotic and grouping the classified the inbred line into 3 heterotic group, but SCA and heterotic group a specific and general combining ability. Both SCA and HSGCA method showing the same breeding efficiency compared to HSGCA MT, SSR and SNP also. Then the SNP based genotyping done by Richard in 2020, a core set of 45 maize inbred lines were selected from 96 maize inbred lines that were obtained from major breeding program from Zambia, CIMMYT, IITA and USA. And based on the SNP data, they are clear-cut classified the lines into different heterotic group and found that SNP based method is more prominent compared to SCA, HSGCA and HSGCA. It conclude that there are different researchers for the different method of heterotic grouping, but recently among the researchers found that HSGCA method is more efficient compared to SCA. Thank you.
Thank you, Pradeep. Now, Dr. Pradeep's presentation is open for discussion. You can stop sharing.
Hello, sir.
Yeah.
Sir, can you explain more about the breeding efficiency calculation?
Actually, in case of breeding efficiency now, suppose that you classified your lines into different heterotic group based on the SCA.
Sir, can you open your presentation, sir?
Yes.
That slide which is showing the breeding efficiency calculation.
Yes.
Sir, in that one second point, breeding efficiency can be defined as percentage of superior high-yielding hybrids obtained across the total number of interheterotic crosses.
Yes.
Here we are dividing the all hybrids into 3 yield groups.
Yes.
Yield group 1, yield group 2, yield group 3. In all the yield groups, we will get the intergroup crosses and intragroup crosses.
Yes. Yes.
And in your second point, you said that superior high-yielding hybrids obtained across the total number of interheterotic crosses means superior means only yield group 1 or including yield group 2?
No, yield group 1. Because we have this divided into 3 groups. First group will be higher yielding, second one will be moderate, and third one is low yield. So in 3 group also, you will find the intergroup, means intergroup in higher yielder, intergroup in medium, and intergroup in lower. Then accordingly, the whatever breeding methods having higher superior hybrid means higher yield, then it will be more efficient.
Sir, but why we divided the yield group 2 and 3 if we need only yield group 1 means why would we divided yield group 2, 3?
Then because if we see the heterotic grouping, the main objective of heterotic grouping to get the higher yielding hybrid. Accordingly, on the basis of higher yielding, which method giving the more higher yielding hybrid, then accordingly we can decide ki which breeding method, which heterotic grouping method is more efficient. Because
Sir,
ultimately for
in your opinion, which type of breeding efficiency calculation is more efficient?
I'm not getting. Can you repeat?
Sir, for the calculation of breeding efficiency, some methods are there, sir, like t-test, and one method you given in the formula like high yield inter-heterotic group by total number of inter-group into 100, like one formula is given as sir. Bado apna course are papers.
Rajashekar, I think you are getting one thing wrong. This that is the methodology how to group them. Now here he is taking these groups and then he is trying to find out that which is giving better yield, and on that basis he is calculating. Am I correct, Pradeep?
Yes, sir. Actually, sir, if we see the main objective of the heterotic grouping to get the higher yielder hybrids, and with whatever heterotic grouping giving the higher yielding hybrid, it means it is more efficient compared to other.
Yes, sir. But our question is that we divided the some inbred lines into different groups.
Not inbreds, not inbreds.
Yeah,
it is for process.
Here you're mixing up. First step is that you make the group.
Yes, sir. We made the groups. After that,
now you have, suppose you had 20 lines. 5 of them have come in one group, 12 have come in another group, and then remaining you couldn't group them. Okay. So now within this 5, if you will find that there will be intergroup hybrids, and there would be intergroup, and there would be intergroup hybrids also. Now, if you put this 5 and 12, whatever combinations you are getting, so these many hybrids you are getting. Now you put them, group them, all the hybrids into 3 groups. So the top, that is the number 1. Out of that, within group, how many you are getting, and intergroup, how many you are getting. If you get more in intergroup hybrids in a particular following one methodology, that means that is giving a better breeding efficiency.
Sir, Devyani here. Can I just ask one question, sir?
Yeah.
Actually, Rajshekar is my student. He's working on this only, sir, with the lines that you have given us. So, sir, we've got different methods for this Hsdca grouping, for this heterotic grouping, sir. So, in order to say which one is significant, we've seen that there are some tests like t-test, ANOVA, and there's the formula that he was trying to highlight. So, which of them should we go for, sir?
Actually, later on, you can do t-test also and chi-square test also to test the significance. You can do.
Okay.
You can do.
Okay, sir.
So you want to mean that you calculate the breeding efficiency following different methodology, and then the difference between this methodology you can compare.
Yes, sir.
Yes,
sir.
sir.
So now with your experience of recently the one which you have communicated, did you do calculate the breeding efficiency based on this Hsdca and SCA alone, and then compare?
Yes, sir.
So what was your observation?
Sir, in our case, it is not significant. Means among both the method, SCA and Hsdca.
So both are giving the same result?
Not same. Means if Hsdca giving the breeding efficiency 48%, so Hsdca is 50%.
Okay, so not very significant difference.
Yes,
but
yes.
You did get some cases where
yes, sir. I explained here only that they are getting significant even over the SSR marker also.
Okay. Okay. So anybody else has any comments?
Sir, this is Rajshekar from Dharwad. Sir, what we are also trying to, we did some 2 PG students, we worked on it. but majority of the times the lines were classifying into another like A and B group only, AB group only, and those lines were performing better. So basically what we feel is the testers are very important in choosing again, when we go on adding the lines, these testers become redundant sometimes. So it is, should we deliberate more on the use of which tester to use, or how that can be thought of?
Can you repeat? Your initial comments were not.
Sir, okay, sir. Sir, we have done some heterotic grouping in our for our students. Majority of the times when you use the two testers, most of the lines they get grouped into AB only, and those AB lines are having very good performance. Then when we go on adding new lines, these testers, their efficiency, what we see is less. So whether we should first deliberate or use more prominent testers, or how to zero in those 1 and 2 testers, T1 and T2. That's the main thing for me, sir.
Yeah, that is you may find that Dr. Basal always talks about improving the testers as well. So at this moment in our national program, what we have decided that LN 13 and 14, because as we have seen that PAU has maintained their heterotic pools very distinctly, and these two LN 13 and 14 are coming from two different heterotic pools, and the hybrid was also quite good. So accordingly, we have taken LM 13 and 14. But and on that basis, we are trying to group all the lines. But certainly, as time progresses, we need to improve upon those testers also subsequently. But yes, as you told that, but you told one thing that like suppose if you are using two testers, you are able to group them, and then the moment you increase the number of lines or number of testers.
Number of lines, sir.
Okay. Then they are not coming into falling into two groups.
Different. They are all together coming into different groups, sir.
No, same lines. For the new lines.
Same 1 or 2 lines are remaining same, but we're not changing, sir. But one thing is that we should go for, I think, multiple trial site evaluation that we have not done. Probably the pool data from multiple sites should be used in a better way to group these lines, I felt, sir.
Yeah, that is very much required. Actually, Dr. Sudha is still there?
Yeah. So I'm listening. I was about to comment on this. So my observation is, by the way, Dr. Pradeep, it was very nice to listen to your presentation, because for us to go back to the entire spectrum of studies that have happened in this field, that was a very good thing for me, actually. But then what I have observed also is like breeding programs use these different ways of classification into different heterotic groups, like based on SCA, using SCA and mean, using GCA included with SCAs, like it happens. So the important fact is, like, we should have two heterotic groups, and using some good methods, we should be able to start a disciplined way of maintaining those heterotic groups, breeding within the groups for line development, and crossing across groups for hybrids. So I think once we start that, so for Dr. Rajshekar's question also about choosing the best tester. So say, for example, if we have not followed that for long time, it is very difficult to pinpoint on 1 or 2 testers as such. But then what Dr. Sujay was saying is right, because LM13 and LM14 is one of the, I think, parents of one of the highest yielding hybrids that happened at one point in time. So that is a good start. But also that had to be looked at is, like, if there is a heterotic group that is there for LM13, within that group, if that line is also having good GCA, that is something that we have to also consider. Otherwise, you will, many of the lines within that group will not have heterosis with in crosses with the other group. So to start with, it's a good idea to start with good hybrid parents, maybe a couple of them, so that we will get at least a pair that is having good GCA within their respective heterotic groups as well. So that is my opinion on that. And unfortunately, I think Vivek is not in this, but I understand that he was using SCA mainly for classification. And of course, considering GCA as he goes by, but that HSGCA method was not the one he was following, if I understand it right.
Yeah. So
coming to
you carry on.
Yeah. So coming to molecular markers, I consider that using molecular markers in our, say, for example, we study the entire genetic diversity within our germplasm and try to derive two heterotic groups from that will not happen, because heterotic groups, which is purely breeder made, and it is based on your combining ability, mean performance, combining ability, also two different kinds of combining abilities, whereas the genetic diversity is based on the entire gamut of diversity that is there within the organism. So to start with, we will not observe that. But when we look at the US heterotic groups and all, we can see clearly two different pools separated based on molecular data. That is because of 100 years of doing it that way. So we have to start at one point where we are choosing a good tester that has given us good hybrids, also which has good GCA within a particular heterotic group, and start with discipline, only breeding within the lines and crossing across the heterotic groups to obtain hybrids. Even if we get something that is really good, it is very, you might in the beginning there may be good hybrids that you might get within a heterotic group, but the breeders should have that thing to not go ahead with that, like just ignore that hybrid. Then only we can actually separate it in due course of time. I would say even Simit's program, after so many years, still we can see mix up of A and B. That is because of sometimes you cannot that temptation to hold on to one of the best hybrids that could come up, because when we are going ahead with grouping, I think we will observe such things. So molecular markers are good as a complementary thing along with field testing. Like, say, for example, field testing, if you cannot distinguish between this and that, whereas you cannot just leave that particular line out of the entire our breeding pool, then molecular markers can be used as a good tool to classify it onto one or the other group based on their genetic distance. So and then in due course, when we do it for many years, I'm sure that based on molecular markers also, we will see a clear distinction between different heterotic groups. So to start with, it should be, and then I don't know how valid that suggestion is, because that was what I observed when I was working with the germplasm, because there is not that much of diversity, across the different centers germplasm also. So we can actually have a combined program, at least across maybe zones or whatever, and have heterotic grouping within those, rather than different centers doing it separately. That will give us a very good data. Very good, because we have also the coordinated programs for testing and things like that. That is one of the excellent things about our program, maize program. So I think we are not making use of that very well, having very, I would say, isolated efforts that without using grouping germplasm across. That's my comment.
Yeah,
Sujay.
thank you, Sudha. Exactly, this is a thing we are trying to do, that under ICR Summit collaboration, that we have taken lines from all the centers, and now Dr. Yatish and Dr. Vivek and his team, they are making the test process. But there again, we are using 4 testers, 2 from your side and 2 from our side. But that again certainly increases the workload. But
Yes.
these particular 2 lines, unfortunately, Dr. Chikappa is not there. He's touring. We made a very elaborate effort in 2017, where I think 8 testers were crossed with a good number of lines. And then the biplot clearly showed that across location, this LM13 or LM14 are coming into opposite group consistently. So that's how we, and we know the breeding background of BAU. So that accordingly, we have decided to pick up this LM13 and 14. Yeah. So that we are doing, and we are making. But I know that Dr. Vivek is also using the SCA alone, and we are also using SCA alone. And in SCA alone, generally it comes into 2 distinct groups. One is positive side and one is negative side. And if you take the significant and other thing, only few will come out as not coming in any group. But as we found that in this particular analysis, what Pardeep did, there we did observe that there are few lines which are coming as that they cannot be assigned to any group. So accordingly, in my opinion, this was coming a better option rather than just relying on SC alone. But when Dr. Pradeep was showing in his 5th slide, if I remember correctly, which I asked him to again show, that why when this SCGCA is positive in 2 cases, then we are not able to define them. Because if suppose SCA is GCA is very high in a positive direction, and then do we ignore that if the cumulative value is coming positive on?
I think probably the problem is because it is good with both.
Okay.
When it is positive, significantly positive on both, probably we are not able to align it to one or the other clearly and ambiguously.
Yeah, but in another case, when it was giving negative and with both the lines, that was giving, we are still putting in wherever it is giving a higher negative value.
Okay. So in that particular formula, it was considering the GCA of the line plus SCA of the hybrid, right? So when we say it is very high, very significantly positive, that means the GCA effect, the GCA contribution of that line is more than how it is contributing in that specific combination with that particular tester probably. So the SCA component is slightly is less compared to the GCA of, the strength of the SCA component of that line with that particular tester is lesser compared to the GCA of that line. So it's a good line. It is a good line probably, but the SCA is not as good probably. I don't know. When I was seeing that formula, that's what I thought.
Okay. So now I request everybody that, as Dr. Sudha was mentioning, that even if we get any good hybrid, I'm not telling that you are just throw it. But what happened, unfortunately, in between, we shifted to a strategy where you take all the hybrids and start deriving lines and put them in combination and start releasing them. And that has actually, to a large extent, mixed up our heterotic alleles. So it is not a very easy task. We'll have to devote a lot of time. But as someone said that when we enter a temple, we remove our shoes. And even if you are having a new shoe, brand new shoe, you have not used it outside, then also when you enter in the temple, you don't wear that shoe. So similarly, as Sudha was mentioning, that even if we get some line which is giving a good hybrid within a group, then also I think those lines we should not involve in our, when we are recycling the lines. So that is we need to follow very stringently. But now I request that since we don't have very good information about heterotic behavior, so now 11, 13, and 14 we are using that, we have taken as a standard. So at least for the time being, let us put our germplasm into 2 groups. And relatively, I request if anybody is having data, you group your material with the following SCA alone and Hsdca and maybe some other method, and you make a comparison, because with Pradeep's work, I found that Hsdca is giving a better picture. So that one, and then we can come to a conclusion, because SCA alone will put them into only 2 distinct groups, and most of the lines will come, in between lines will not be coming out, but here it has come out. So those things we are certainly going to rule out. So in that way, we need to proceed in days to come. So anybody else is having any other comment? Dr. Kachanur, is your question answered?
Sir, fine, sir. Definitely, sir. The LM13, 14, as you suggested, we also try.
There is some network issue, I believe. No, one thing, you can use your own tester, but at least you should know in terms of your LM13 and 14 where your tester stands.
Okay, sir. Okay.
So that at least again we'll have to then suppose you tell that this is the 2 heterotic group, but we don't know now. Suppose if you are exchanging your material with somebody else, and again they will have to cross it with LM13, 14, and then they will. So whatever tester you are using, like in case of ICAR Summit collaboration also, what we found that so many lines, I think it is Yatish, how many? 500 plus, no? So making with 4 testers is a huge number of process which we are not able to do.
So lines are 650, sir.
Yeah. So now within these testers also we have made process, and so that we know that LM13 is heterotic to which tester of Summit, and LM14 is heterotic to which tester of Summit. So in that way we are planning. So anybody else?
Okay.
And sir, I want to mention one thing. And in the selection of tester, when we see the calculation and see the GCA of both the tester, it will be divergent. Means one tester should be GCA negative or one should be positive. If it is showing both negative or both positive, it means these testers are not diverse.
No, Dr. Pradeep, it is not GCA, it is SCA. GCA will be 1.
No, sir.
No. What Dr. Pradeep is telling that if you are
GCA will be,
one tester should be positive GCA and one tester should be negative GCA.
Okay.
So in your study, you obtained that situation? Dr. Pradeep?
yes, sir. It is coming in our case.
Okay. So Dr. Ratish, I will request you that you please discuss with Vivek, because the exercise which we are making under ICAR Summit collaboration, there at this moment only SCA is taken into consideration. But I think this would be a better strategy. Okay. Yeah, and whatever data you have, you can work on that. So anybody else? Dr. Sunil Karad, Dr. Ravi, Dr. Sahi, anybody else wants to add anything?
Ravikeshan here.
Yeah.
Sir, actually, when we are taking SCA, the SCA also varies between the locations. It may not be same. If you are testing your hybrid at our location, SCA will vary.
Yeah. Due to G.
So in that case, if you are making a heterotic group, that will not be useful for me. If you are taking SCA as a basic one.
You want to mean that if we are using multi-location data, then how you will proceed?
That's why I'm asking. So what we can do, we'll have two testers in common for all the centers.
Yeah.
And to go for crossing with the lines which are available at their location. And we have to see whether these testers are working with all the locations.
Let us wait. I think, Dr. Yatish, this time you have sufficient number of test cross to be evaluated. No?
We are evaluating in 3 locations, sir, this time.
Yeah. So let us wait for the data and
Okay,
then will come out. But this is, I request everybody that please focus on proper heterotic grouping of your material. Otherwise, the way we are proceeding, it will land up nowhere. Okay. So anybody else? If not, then I thank Dr. Pradeep. I think he has just thrown some light. We need to work, think more carefully in this direction and move ahead. But as we repeatedly, I was mentioning that heterotic grouping of our material is very much required, and that's why all these 600 odd lines which we have pulled from different AICRB centers, we are doing this analysis. And subsequently, our recycling of lines should be done within the heterotic group rather than between the heterotic group. With this, I thank once again Dr. Pradeep and all our colleagues from IAMR and AICRP for spending nearly 1 hour time. And I am very hopeful that in days to come, we'll be able to come out with good information. Thank you.
Thank you, sir.